In this section, we are going to talk about dividing polynomials. We will start by talking about long division of polynomials. Now, you're going to find that long division of polynomials is very similar to the way you learned long division in elementary school. So let's start with an example. Let's say we want to divide x squared plus 14x plus 45 by x plus 9. All right, we start by just writing it the way we would any long division problem. We've got x plus 9, divided into x squared plus 14x plus 45. All right, now, you look at the first term in the x plus 9 is the x. How many times does that go into x squared? Well, if we look at that, that goes in x times. So we'll write an x over the 14x. Then I multiply the x times the x plus 9. So what do I get? I get 9x, x times the 9. Then x times x is simply x squared. And of course there's a plus here. Now I'm going to subtract these two. X squared minus x squared is 0. 14x minus 9x is 5x. Then I bring down the 45. Now I look at how many times does x go into 5x? Well, that's simply 5. So I say plus 5. Again, I multiply it out. 9 times 5 is 45. And 5 times x is 5x. And there's a plus there. Then if I subtract these two, I get 0, or no remainder. So the answer for x squared plus 14x plus 45 divided by x plus 9 is simply x plus 5. So let's look at a more complicated example. In this case, I want to divide 2x to the fourth plus 3x cubed minus 7x minus 10 by x squared minus 2x. So let's see how we set that up initially. So initially we set it up the same way we did before, with the x squared minus 2x outside the dividing sign. And then, but underneath, notice what we've done. There's one slight change. I've added another term. I've added a 0x squared term because there wasn't one originally. So you must have all the terms there. You must have the x to the fourth, the x to the third. You must have an x squared term, even though it's 0x squared. Then we have an x to the 1, plus then we have a constant term. So make sure that you have all the exponents in descending order before you start dividing. All right, at this point we're going to take the x squared and we're going to divide it into the 2x to the fourth. And we're going to get 2x squared. So the 2x squared I'm going to place over the x squared term. So we got 2x squared. Okay, now we're going to multiply. 2x squared times minus 2x is minus 4x cubed. So that goes under the x cubed term. So we got minus 4x cubed. Then the 2x squared times x squared becomes 2x to the fourth, and that goes under the x to the fourth term. Now we're going to subtract. When we subtract, notice that the negative 4 changes to positive, so our result is 7x cubed. All right, bring down the next term, which is plus 0x squared. X squared into 7x cubed is 7x, so we put a plus 7x. All All right, plus 7x times minus 2x is minus 14x squared. Then 7x times x squared is 7x cubed. Now again we subtract, again the minus sign changes, and I get 14x squared. Then I bring down the minus 7x. X squared goes into 14x squared 14 times. Then I multiply the 14 times minus 2x, which is minus 28x. Fourteen times x squared is 14x squared. Now we subtract. Again, the sign changes, and we get plus 21x. We bring down the minus 10. Now notice, x squared can't go into 21x, so at this point, this 21x minus 10 is simply the remainder, okay? Well, how do we show the remainder? We show the remainder up here as plus 21x minus 10 over x squared minus 2x. So there's our result. In this case, we have a remainder, so our result is 2x squared plus 7x plus 14 plus 21x minus 10 over x squared minus 2x. All right, now we're going to talk about a different way, and in some respects, some people feel it's an easier way to divide rather than doing long division, and that's using synthetic division. So let's start with an example. So let's say we want to divide x cubed minus 7x minus 6 by x plus 2. All right, so first of all we're going to be concerned with is the coefficients. We start off with by looking at the x plus 2. Well, if x plus 2, we're dividing by x plus 2, then I want to put minus 2 in this little box here. Okay, if I had been dividing by x minus 2, then I would put plus 2 in the box. Okay, so I put minus 2 in the box. Then I list all the coefficients. Now, notice, again, we must have all the coefficients for all the terms, even if some of them aren't there. For example, the coefficient for x cubed is 1. There is no x squared term, so the coefficient for that must be 0. The coefficient for the x term is minus 7, and then the constant term is minus 6. All right, this is how we proceed from here. Step 1 is you take the 1 and you bring it down, okay? So you bring the 1 down. Then you take the minus 2 and you multiply it by 1, and you get minus 2, and then you stick that under the 0. So I add 0 and minus 2, and I simply get minus 2. Then I multiply this minus 2 times that minus 2, and I get plus 4. I add those two terms, and I get minus 3. I multiply minus 2 times minus 3, and I get plus 6. I add those two, and I get 0 for remainder. All right? So, what is my result? Well, the numbers here that you get are basically the coefficients. So our answer would look like this. So this is our answer then. Using the coefficients that we got, we come out with x squared minus 2x minus 3. Okay? So this leads us to the first of two theorems in this section, and this theorem is the remainder theorem. So the remainder theorem simply states that if f of x is divided by x minus c, the remainder is the function evaluated at c. So if I use this definition in my previous example, I'm basically going to be looking for f of minus 2. So I'm going to plug in place of x, minus 2. So x cubed is going to be minus 8. Minus 7x is going to be plus 14. And then, of course, we get minus 6. So I got minus 8 plus 14, which is plus 6, minus 6 is 0. And that is indeed what we got for the remainder. The remainder was 0 for this example. So now we'll talk about the other theorem, and that is the factor theorem. So the factor theorem states, if x minus c is a factor of f of x, then f of c is simply equal to 0. Well, that might be a little hard to understand, so let's look at an example and see if we can explain it better. All right, so here's an example we're going to use. Solve 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that minus 1 is a 0 of the function. All right, so how are we going to proceed from here? All right, so I'm going to set it up the same way I did with synthetic division before. Minus 1, remember now, is a 0, so that's what I put inside this little box. And then I put the coefficients in descending order. So I bring down the 15 initially. Then I multiply that by minus 1. That'll give me minus 15. Then I add those two numbers and I get minus 1. Minus 1 times minus 1 will be plus 1. I add those two numbers, I get minus 2. Minus 1 times minus 2 is plus 2, which gives me a remainder of 0. So this tells me immediately what my answer is. So knowing the coefficients, my result is 15x squared minus x minus 2. Well, this is just a standard trinomial, which is factorable. And let's see. So if I were to factor this, I would find that this comes out equaling 5x minus 2 times 3x plus 1. Which gives me all the zeros for my original cubic polynomial. I know that minus 1 is a 0. And looking at the results I just got, if I set 5x minus 2 equals 0, I realize that another 0 is 2/5. And then if I set 3x plus 1 equals 0, I'll get the third 0 is minus 1/3. So we've got our 3 solutions for this cubic polynomial. All right, finally, I'd like you to solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of the function, and post your answer in the drop box.